Hello, my name is Mr. Fontenot. Welcome to my YouTube channel, Mr. Fontenot 1111. Please like, share, subscribe, and if you find this video helpful, if you enjoy my teaching style, please leave a comment. In this video, I'll be making the calculations for problem number 3 of the Chapter 21 math handout. If you have any questions about the steps that I take to solve this problem, the electrical quantities that I'm looking for, where I'm getting my known values, or the formulas that I'm using, please view the Chapter 21 math handout instructions and overview video. I will leave a link to that video in the comments. So we see here our given values, and we are getting those from the Chapter 21 math handout, problem number 3. And my primary voltage is 120 volts. My load resistance is 25 ohms. That's the resistance of my secondary. The number of windings of my primary is 4, and the number of windings of my secondary is 1. And I'm going to put some of that information on my transformer schematic here because it's always helpful to fill that information in. It fills in a lot of the blanks for us so that we're able to mentally have a picture of where things belong. And you may want to pause the video and fill this information in for yourself here. So I've got 120 volts on my primary. It's a 4-to-1 step down ratio, and I have 25 ohms of load resistance. Alright, so the first step I'm going to take here, I'm going to calculate the voltage of my secondary. And I see the formula I'm going to use, formula number 1. So I'm going to put the number of windings of my secondary in first, which is 1. Hit my over under button. 1. Hit my over under button. And the number of windings of my primary is 4. I'm going to scroll over times the voltage of my primary, which is 120 volts. And this gives me 30 volts on my secondary. My next step, I want to find the current of my secondary. I do that by taking the voltage of my secondary, which is already in my calculator, and dividing it by RL. RL being 25 ohms, so I got 30 divided by 25. This tells me that the current of my secondary is 1.2 amps. Alright. The next thing, I'm looking for the power of my secondary. And the power of my secondary is going to be equal to the current of my secondary, which is already in my calculator, 1.2, times the voltage of my secondary, which I had calculated earlier to be 30 volts. So I'm going to say 1.2 times 30. This gives me 36 watts. Because I'm using the power formula looking for watts, so the power of my secondary is 36 watts. Alright, now I'm moving back over to the primary side of my transformer, and I see here that the next thing I want to do is find the primary power. And my formula tells me that my primary power is equal to my secondary power. So I've got 36 watts. It'll be 36 watts on the primary side. Alright. Still on the primary side. Now I want the current of the primary. And I'm going to looking for the current of the primary, I take the power of the primary, which I just calculated to be 36 watts. It's already in the calculator. And I'm going to say divided by the voltage of the primary, which is 120. So 36 divided by 120 volts. It's going to give me a current. I was looking for current of 300 milliamps. Primary current, 300 milliamps. That was step number 5, looking for primary current. And I used the power formula, a rearrangement of the power formula to find it. Alright, my last step here, I am looking for the impedance of the primary. That's what the letter Z tells us, impedance. It's measured in ohms, just like resistance. And so what I'm using here is just a fancy form of Ohm's law. So I take the voltage of my primary, which is 120 volts, and I hit over under, and I'm going to use the current of my primary, which I calculated to be 300 milliamps. So the impedance of my primary is 400 ohms. Now there is another formula that we could use to find the impedance of the primary, but for right now we're just going to stick with our Ohm's law formula. Thank you.